Hey, how's everyone doing? You all having a nice time at phptour? Yeah. Hey. So I'm here to talk to you today at phptour about JavaScript, because that's what everyone comes to a PHP conference for, JavaScript. And the reason I'm doing this is because the better you understand the environment that your code is going to run within, the better you can develop for. And we spent a lot of time during this conference looking at the server side of things, and now I'm going to turn this around and spend a bit of time looking at architectures that work well with modern JavaScript development techniques. So I'm going to be looking at MVVM frameworks, and I'm going to give you some ideas about how you might architect your code to work well with them, particularly in a microservices environment. Okay, so what are the goals of this talk? By the end of this talk, I hope you have a working knowledge of JavaScript frameworks on the server side. You have a working knowledge of client-side JavaScript frameworks. You know how you might integrate them with PHP, and you feel confident enough to call yourself a cross-stack developer. Who here, can everyone put up their hands who considers themselves a cross-stack developer already? Hey, there's already a few of you out there. That's fantastic. So who am I? I'm Billie Thompson. I'm a contracting software developer. I've been contracting for about 3 years, and I've been a developer for about 7. During that time, I've been really, really lucky. I've got to work on all over the stack. I've got to do front-end only projects. I've got to do back-end only projects. I've done some DevOpsy type stuff, and I've even helped train some testers. And the patterns that I'm going to be describing today are patterns which I've seen reoccurring more and more frequently through the past 3 years of contracting. Okay, so imagination time. Your boss has pulled you into the office, and he wants you to set up a small team of developers, your boss business cat, who conveniently runs a bookstore because you can't trust him to run a pet store, he'd eat all the budgies. And he wants his bookstore to beat Amazon. So he's hired you a small team of cross-functional developers. You're going to help architect it, you're going to help design the front end, design the back end, and work out how it's all going to play together. But you've only got a really small team of people. So you start talking to the business, and you start discovering that there's 2 main sources of data. So as they come into the shop and as they leave, customers leave little ratings, little 5-star ratings on slips of paper. So you have a single source of information there, and you can collocate that into a single source of truth as a rating API. So you have a rating API which is going to contain information about what customers think about books. And also, publishers provide you some information as well. So they provide you with some information about what's on the jacket of the book, some pretty book covers, the ISBN number, things like that. Now, because 2 APIs are probably going to return lots of data which maybe you aren't terribly interested in, you probably don't want to be calling those directly from the front end. So we're going to see about putting an intermediary layer in between there to customize the output for the specific application that's using it, a middleware layer. And then we're going to develop a small JavaScript application on the front end. So rather than rushing into this and not specifying any technical choices or why we might choose certain things, I think for the back end of our code, we need to make a choice which is really good for interacting with databases, is really solid for business logic, and it's really easy to interact with queues and to make general decisions about how you're going to model the business data. And then for our intermediary layer, which is going to customize data, we want to be able to make lots of requests in parallel, because it's going to be calling multiple APIs, and it needs to be able to customize those APIs. It's also going to serve the front end temporarily, and it needs to be written in a way, because it's going to be heavily interacted with by the front end, that people who specialize in front end code can easily approach it without high amounts of cognitive dissonance between the styles of programming. And then on the front end, we're going to choose a full stack JavaScript framework, because we don't want to get into the situation where we have hundreds and hundreds of files of code and no real structure to it and no ability to reuse things that people have already made. Okay, so I think for the back end, Silex makes a pretty good choice. because this is a PHP conference, and I had to include some PHP in here. It's built on top of Symfony components. It's great for little APIs. Can everyone put up their hand who's used Silex before? Hey, okay, cool, a few of you. Oh, don't worry, I won't go into too much detail with that. I'm also going to be talking about Express. Express is a server-side framework which works with Node.js. Node.js is a wrapper for JavaScript. It basically takes the V8 engine out of Chrome and allows you to run that as for client-side, server-side scripts. And I'm going to be talking about AngularJS on the front end. And the reason I'm going to be talking about AngularJS is because it has a large number of plugins, fantastic documentation, and so you as a back-end developer would be able to approach it very, very easily and help out front-end developers when you have a feature which is perhaps more front-end based. Okay, so if you want to load up the code, it's on there. You can visit my GitHub. They're in repositories which match the names there, and you can see it on Heroku as well. Everyone seen that? Who wants to see it? Cool. Okay. So now I'm going to be talking about Silex. I won't go too much into this. Basically, all that's required to get something up and running with Silex is a single PHP file, and this single PHP file has some roots and stuff in it. You pull in your dependencies with Composer, and it's built on top of Symfony components. And the two little bits that I'm going to be looking at are the book jacket API and the rating API. Okay, here we go. Let's see if we can do a demo. There we go. Okay, so this is just about as simple as you can get for the rating API. Try and move that a bit more into the center. It's just a rating that we get back for a number which is an ISBN. You can see the ISBN in the URL up there. It's sort of RESTful. There's no hyperlinks in there, but so maybe it's only level 2. And then again, we have a book jacket API, and this just contains a list of books. And you can even visit a URL and get information about a specific book. Like that, which is pretty exciting. These are all my favorite sci-fi books, by the way. So if you want to get some recommendations for what's good to read for sci-fi, providing you can read English. Okay, so let's do this. Right, okay, so I'm not going to show you the code inside the editor because it gets really small and it's quite hard to read. But this is your index.php. Now, if you just have a look at the key elements of this, all you really need to get a Silex application up and running is to instantiate the Silex object and then call run after including the autoloader for Composer and including it in your Composer file. But this is pretty useless without any roots. So we need to add in some roots to make this actually useful. This is the simplest sort of root you can add in with Silex. You can see there's a parameter there, the name one, and it gets passed into the function, then it returns a string, and the string's what gets sent to the user. But, I mean, you could imagine if you've got one for each of the verbs that you can do on a resource, so get, put, post, patch, head. This is going to get quite messy even with really simple code, so there's a much better way of doing this, and that's by using classes. The reason I mention this is to highlight that Silex is built on top of a dependency injection container called Pimple, and with Silex, pretty much everything that you can do with it can be registered as a service. So here I'm registering the books controller as a service after saying that I want to allow services to be loaded in my application by using this middleware layer. And now you can see at the bottom I've got a couple of roots. So there is get by ISBN, and that loads the get action, and then we have the index action. So I'll just give you a quick rundown of the controller. So the controllers look like this. They're just plain old objects, which is fantastic because you don't want to muck up your object hierarchy. It's really simple because you just return a Symfony object. So if we look here, this is the get action in a bit larger font. You can see here that I'm returning JSON response. you can return any response at all from any response object, which is a Symfony response object from these controllers, and it will output it. For convenience, I like to use a JSON response because it changes the response to a JSON object, which is fantastic. It saves you loads of time. So Silex is fantastic for doing rapid API development. It uses really familiar libraries. It uses Symfony, which is great. And it's absolutely perfect for small services. Unfortunately, it's not so great when you're not using quite so small services. So if you're doing something other than like a little demo app like this, then maybe you should have a look at using API Agility, Zen Framework 2, or Symfony. API Agility is a really nice framework for developing RESTful web services. It is built on top of Zen Framework 2, and it just offers you a really nice wizard to generate a RESTful web service based on your database and some hooks to do non-CRUD type stuff. Okay, so that's the first framework done, and that's the boring bit, I think. We'll do the good bit now. Can everyone hear me okay? Yeah? Cool. So let's talk about front-end frameworks. There's probably 3 main front-end frameworks that you have heard of. There's probably the biggest one you've heard of is AngularJS, and that's what I'm going to be talking about today. But there is also Ember, which is out there. And the third framework, which is a JavaScript framework that you've probably heard of recently, is React. Not the PHP React. Facebook have done a component-based JavaScript framework for the front end. I personally find that it doesn't work for anything other than heavily componentized UIs, like Facebook's UI. But it might be worth investigating if that's something that you're interested in. Okay, so the code that we're going to be looking at now is going to be loaded from the middleware and is going to be ran in the browser. So I think I should probably tell you what MVVM stands for. So MVVM stands for Model, View, and View Model, or Model, View, View Model, if you say it in order. So I want you to imagine a sign-up page. Now, a sign-up page in HTML, and then you've got it loaded in your browser. And at the bottom of the form, there's a big button, with a nice, clear call to action, like sign up or click me. And you click on it, and what happens is it raises an event. That event gets sent up to the view model. The view model listens for this really HTML-specific event and turns it into something more meaningful. So it turns it into a user is signing up for our web service event, and then this then gets passed on to the model. The model then sends it to a remote API, puts it in local storage. Now, this is all pretty similar to RESTful web service, standard MVC framework at the moment, but there's one major difference. And the difference is that actually we can push data the other way. So the model can be polling or requesting information from the web service all the time via via HTTP sockets or via some other method. And it can, when it gets some new data in, such as a user signing up for our web service, it then fires another event, which is user signed up for our web service. It goes to the view model, and the view model then updates our view, incrementing the number of users signed up for our web service. So it works both ways. So AngularJS is pretty popular. However, popularity alone is never a good reason to use a framework. The main reason that I think AngularJS is a really good choice for making a framework is there's fantastic documentation for it. There's lots of plugins for it, like ng-resource, which I'll talk a little bit later on, and it's really well documented. Okay, so I'm going to show you the fantastic front end. Okay, so you can tell that I'm not a designer. So here we have a really simple list of books. This is what's coming from our API. And then you can click on the book, and it'll take you to a few details about the book, and it'll show a pretty picture and things like that. Now, I don't know if you can see at the top, but this is all from a single page request. The URL at the top is still just slash. We don't make another round trip to the server in order to get that. What we do load is partials, and I will come on to talk about that in a second. Okay. Okay. So When I said that a single round trip is made to the server to load the page for the first time, this is what is loaded. So we load a index.jade. Now, Jade is Express's standard templating language. I won't go into talk too much about this. It looks pretty simple because it is. So space means put it inside the element, and brackets means make it an attribute. So this translates to this. Okay, so let's have a look at some of the things that are happening in here. So we have 3 assets which we're loading, which are built in, that come from AngularJS. The first is app, which is the main part of AngularJS, and it gives you support for creating controllers, for creating modules and things like that. And then we have Angular Resource, which allows us to really quickly make RESTful web clients. And we have Angular Root. And Angular Root allows us to visit specific pages from a single page. So I'll come on to that, how that works in a little bit. Typically, I like to use Bower to pull in my front-end dependencies just to keep them separate from everything else, but you can use NPM or whatever you want. And for this application, there's only like 3 files. So we have an app.js that defines some routes. We have some services. Now, these services match really accurately to the model. And we have some controllers, and these map really closely to the view model. OK, so let's talk about the app.js. Now, the app.js is our main file, basically, for this application. And there's a few things to notice. So firstly, we set the scope that we want our application to run within. And our application is an Angular module. So you can see here that we define an Angular module, Books app, and that the app matches up with a name in the HTML head with an ng app tag, Books app. These next things are dependencies that we're going to inject into our service. Now, these services are very much like Silex services. It's like getting multiple dependency injection containers and combining them. So ng resource, clients, root, different pages, book service is our model, and books controllers is our view model. And we need to do a little bit more configuration than this. We need to say which particular routes are going to get hit when we visit which particular URL. Now, just like a proper PHP framework, you can load partial templates here. So we have a template URL, and at that template URL, we actually have a specific template that we want to be loaded, and we can specify which controller is going to load this and insert data into the view. We also specify, again, we narrow down the scope that the application is looking at by setting a div ng view, and this is the place where the template is going to be inserted into. Okay. So the multiple pages works by changing the fragment identifier in the URL. If you visit /, then you get the index page, and if you visit that, you get the details page. This is what one of the fragments looks like. So this is the index controller fragment. So this is what draws the list. There's a few things that you might want to see. There's the ng controller, the index controller, and we have ng repeat, which says repeat this element for every single time that we have a books variable, and it will output into a nice, pretty list. All of these templates are evaluated on the AngularJS side, on the client side, apart from the title, which comes from the view. So this is what our controllers look like, our view model. Now it's a bit big, so I'll make it a little bit smaller. And we have the index controller here. So this is what populates that partial template that I showed you before. So again, here we have more dependencies that we're injecting into this. The first one is $scope, and $scope represents all the variables which are available to the specific view we're looking at. And by changing this variable here, we allow ourselves to update the view. Now, in this case, we're just doing a static request, but in a little bit, I'll come on to how we can update this in a more dynamic manner. Okay, so this is what our model looks like as well. Just really quickly, we're going to reuse a pre-built resource which comes with AngularJS. It's one of their modules. It's optional. You don't have to include it, but I have. And it allows you to make clients for RESTful web services. So you just pass it a URL, for a specific resource, and then it will generate a client which has get, post, put. So it saves you loads of time and coding. And $timeout is an accessor to the timeout function. So I promised that this would allow you to push data in both ways and give you a sort of application-like interface rather than you reload the page and then you have to reload the page to get new data type interface. So how do we do that? Well, we do this by updating the scope in a callback. So here you can see that we're passing a callback. We're starting a callback when we visit the details page, and we're going to reload the book scope every time we get a book. And then we're going to use a promise here to, when the scope is destroyed, stop updating it, because we don't want to get loads of extra data that we're not using. Okay, so this is how the models work. It's pretty simple. So all I've done here is extend the API get functionality from the client to add a new method called pushGet, which is called every 4 seconds once it's called, until you stop it, and then it'll cancel the timeout. So that's how to do basically MVVM style programming for a RESTful, for AngularJS. And there are, like I said, a few different alternatives to this. You can use React's component-based approach. I find that it doesn't really match many of my applications' usages. And there is, of course, Backbone if you want to make something more yourself. And Ember. I don't really like Ember, but I thought I'd put it up here anyway because it always gets brought up. I found that the documentation's really out of date, and for me as a PHP developer, it's really difficult to come into JavaScript land after doing loads of PHP development and not have anything to look at. Okay, so this is kind of the future of web development. The way that I see it going is that we are going to have more and more applications which are JavaScript applications, and then we have a customized API which sits in front of them. It has a lot of similarities with server-side software development, and it's really fast because the initial page load is really quick, and then everything else we can do in parallel, making multiple requests from the client. It's a lot faster and easier to understand than it appears. So I hope that at some point that you guys could go up to your front-end developer working on an AngularJS project and jump in and help them. Okay, so I'm going to talk about Express, which has a really boring logo. It's just the word Express. I'm going to tell you a little bit about the middleware layer now. So this is going to serve our AngularJS application. It's going to provide APIs for our front end, and it's going to be touched quite a lot by our front-end developers. And it's going to be for making lots of API calls fast. So we've chosen Express because it's a non-blocking, it's built on Node.js, and Node.js, pretty much everything is non-blocking in Node.js. And what we mean by this is we make a request in a blocking system like standard PHP without React. We would go, oh, I'm going to make a request to the BookJacket API, and then wait. And then make another request to the rating API, and wait. And then finally we'll get both of them back, and we'll be able to combine them together. But we have to make them one after another. Whereas with non-blocking, we can fire off 2 requests and do them in parallel. So we can take 2 requests, fire them off in sync, and then when both of them have the data in, we can combine it to make a single response that we can push out to our clients. Okay, so I'm just going to quickly show you the front end. Again, so you'll notice here that there is the rating, which is updating all the time, and this comes from here. So we have a little rating, and it's combined. But actually, if you look at the BookJacket API, this isn't included in there at all. Oh, right, yeah. Sorry about that. Okay, so here we have the UI again, and you'll notice that the rating is not being displayed. There we go. You'll see that the rating is changing every 4 seconds. Now actually, if we have a look at the BookJacket API, that doesn't have a rating in it. The rating comes from here, the ratings API. So it changes every time we make a request due to customers putting data in. So we need to combine that in some way to get it to our front end. Now we're going to do this inside our middleware layer, which is Express. Okay, so this is what our Express file looks like. It's really long, and I won't show you all of it because it's boring. Mostly, you get most of the Express from, it has a template generator. You just tell it to generate you a template, and it will put pretty much everything in place. The bits that are actually interesting from this, though, are these. So we have some routes, and we're including an index route, and that is the bare minimum bits of JavaScript where we are going to that are going to be loaded to the page. It's what the AngularJS app starts from. We have the book API, which is some routes which is version 1, which doesn't combine any of the data from the results API. It just shows you how to make a client. And we have the book API v2, which actually combines data and makes requests asynchronously. We're also loading a modules directory from the Bower components. Like I mentioned earlier on, I like to use Bower to pull in my components, pretty much the same as Composer, but with more of a front-end sort of bent. And you can then mount these routes off specific URLs. Okay, so this is what the AngularJS index looks like. This is the part which serves the AngularJS application, including the partials. So if we called get on slash, it would tell it to render the index. Now, render loads a Jade file. You probably recognize it as the one from the start, from the AngularJS part of the talk. And here we have here we have the book API. So there's a number of different URLs here, and this is these make requests to a third-party API. So here we have the get one. So what this is going to do is it's going to make a call to an API client, and it's going to load the data, and then it's going to return it as JSON. Here we have, and this is just a really thin wrapper around the Node HTTP library. The Node HTTP library is really good. It's built in, but I had to make 2 requests to 2 different APIs, so I made it a client. And this is what this looks like on the inside. Now, this structure is why Node.js is so fast and what makes it really suitable for a middleware layer. It's based on callbacks. So you can see here that what we're doing is, although we're saying, oh, I want to do a get, we have some promises here. So we have, when we're receiving data, then write it into a variable. So actually, all the time that we're not writing data into that variable, we can do other things. We can run other parts of our Node.js application. We can do processing on other sources. And then you can see at the end, we just pass the JSON that we get back from the API and return that. Okay, so I did promise that we would show you how to combine the two together. Oh, yeah. So the API that we actually hit as part of the endpoint looks a little bit like this by default. But actually, this doesn't have all the details we need. So if we go to v2, I can't show you that. Okay, cool. You see an endpoint which actually requests the data over and over again. Cool, and this works like this. We make a request. So this is what the API routes look like, but you don't need to see all of this all at once, so it's a bit long. We're actually taking advantage of a number of different API clients, different built-in Node.js functions with this. So we're going to take advantage of the async library. And the async library is allows us to make multiple requests at once. It's very, very similar to React in PHP. And here we're using the simplest functionality, which is just to do the two requests and combine them. And then we have we're going to utilize underscore as well, which is like jQuery, but without the jQuery without any of the querying stuff for HTML. Okay, so that's about it for Express. That's roughly how to do it. So if you don't really like Express and you think that it's going to be much better if you can stick with PHP for your entire stack apart from the front end, then you can always use Guzzle, which uses Guzzle Futures, which are built on top of React. You can use PHP and queues. You can combine, create a multi-service environment based on CQRS or something like that and use PHP for your services for that. That would also work and offer you an asynchronous client. And you could use Go or another language which supports parallelization really, really well. So I think the key things to think about Express are that it's non-blocking, it's front-end developer friendly. We want to minimize the amount of cognitive dissonance we cause people. We don't want you to have to think in an entirely different style if you touch two different systems. And it's pretty lightweight. Well, I still got quite a lot of time, so I might as well show you Grunt as well. So the thing to know about Express is that it's built on top of a framework which is an application framework. So unlike you used to in PHP, where every single request is the entire lifespan of the application, with Express, what happens is the application starts, and then in order to load any new changes, you need to restart the application. So to restart the application, you normally would have to stop the application and start it again. But what you can do instead is you can set up Grunt to restart it for you. Now, Grunt is a task manager, kind of like Thing. So Thing had all these big aspirations for that it would fulfill loads of tasks automatically for you. It would check your PHP results and it would your PHP unit results, and it would make sure that you were above a certain ratio. It would fail the build and things like that. But it never really took off. And personally, I always found it fairly clunky to use. Fortunately, Grunt actually managed to do this. So Grunt, as a build tool, allows you to do lots and lots of cool things. So with Grunt, you can tell it to do a number of what they call tasks. And if I start my ID, there we go. I can show you my Grunt file. Now, the Grunt file is a lot like so the Grunt file allows you to I don't know if you can read that. Okay, so at the file you specify a number of different tasks. Firstly, you load the things that you're interested in. In this case, it's contrib watch. Contrib watch will do something and then watch for file changes and then do something again. Here I specified it to run the dev server and then watch for file changes. So if I were to move this over here, and then I make a change to let's have a look. Let's change one of these random files. So I've touched app.js. Let's see if I can. Has it changed? Oh, and it hasn't restarted the server, so that's a bit of a rubbish demo. Okay, so that's a live demo, so these things happen. Has anyone got any questions about any of the things that I've talked about so far? A few things went wrong there. Anyone? Okay, cool. So yeah, so in conclusion, cross-functional teams require you to have knowledge of more than just PHP. They're only small teams, and you're going to have to learn how to interact with other people in them, be them front-end developers or DevOps people. And MVVM frameworks are definitely a large part of the future of that. And if you can step up to the plate and either develop an API which is more suitable to their needs, or develop their front-end API, help them develop a front-end API which is going to work really well for them and only return fields that they want in a language which they understand, and that's going to be fantastic. And really importantly, use middleware to hide your database services and present a per application front-end. Yeah, so hopefully your boss will be really happy and they'll reward you. Has anyone got any questions? And please leave feedback at the joined in URL. That would be absolutely fantastic if you could do that. Cool. No questions?